A relation is what we term, listening up please, basically a relation is what we term a bunch of coordinates put together. So any graphs that you've ever come across, that you've ever done ever, linear graphs, quadratics, parabolas, cubics, are all live under the big umbrella that we call them relations. So rather than necessarily call them graphs, we call them relations. The reason is that graph itself is a huge word. Because if I say we're going to be studying graphs, some people might be thinking we're doing bar graphs. No, we're not in grade 6 anymore. But suffice to say, I should be making fun of general like that. Anyway, so the point is that relations are referred to specifically the kind of graphs that we've been studying, things like linear or straight line graphs, parabolas, and so forth. With this particular type of naming of relations, we have two sets of names that we talk about, and basically it's just a way to describe certain graphs. So they call it, the definition we say, for a bunch of coordinates, we use a proper grown-up phrase, and we call this ordered pairs. So this is another way of saying ordered pairs is a bunch of coordinates. So if we've got a string of coordinates, we call that a set of ordered pairs. And so they give a line or equation. We have different types, of course. So we have, for our friends here, we've got the one-to-one function. And the graph has one x value for every one y value. A great example of an example. Great example of an example. That's a fabulous sentence you've got going on there, Mr. Ernest. Is a linear graph. Okay, so that means for every one x value, there's only one possible y value. So that is why we call it a one-to-one function. So at -3, it has every x value has a unique y value. So if I was to draw another set of circumstances here, as another set of circumstances, if I just had a series of dots, okay, that would also be a one-to-one function if I was to connect them all up together. If we did like that, yep. If it's some weird wiggly graph, that would also be a one-to-one function. So we also have another type of function as well, which we call a many-to-one function. And a many-to-one function is when the graph has many x values for one y value. So what that looks like in reality will be something like a quadratic. For every one y value, there'll be multiple x values. So for example, if this is y equals x squared, if I had the value 4, for instance, if I had y equals x squared and y was equal to 4, what would x be equal to? What are the two possible values for x? Yeah, 2 and -2. So, -2. +2. So this would be an example of having many x values for only one y value. Okay, so those are two functions. The other two don't get to have the fancy word function, and we'll talk about why some things are called functions and some things aren't. But the relations that we've got here, there's a one-to-many relation. And a one-to-many relation is when there's one x value for many y values. So for example, if I have something like this, I'll move this friend up. It is a drunk parabola. It should go home. Okay, so if I've got if this particular value here, I've got this is actually two lots of square root functions put together. But yeah, this is an example of a relation that has one x value. So if this is one value of a, that has multiple y values. So a one-to-many relation has one x value for many y values. And then a many-to-many relation, as it sounds like, is that it's many x values for many y values. Okay, so something like a circle is a many-to-many. It's because for one y value, it'll have multiple x values, but also for one x value, it'll have multiple y values. So it's like a cross between all of these all merged into one. So these are examples. And your job to be able to see is to be able to identify if something is one-to-one, many-to-one, one-to-many, or many-to-many. And we'll talk about the difference between functions and relations very shortly. But those are the four main types of sets of ordered pairs that you ever have to deal with. Those are the four main different types of relations we ever have to deal with in our lives. If you're curious, a cubic graph comes in two forms. This is what y equals x cubed would look like. Looks something like that. But if I also... It also can look like this. And it could also look like this as well, if it's been factorized with 3 sets of brackets. So just to remember, a relation is the big umbrella term for all the kinds of graphs we've been studying in advanced maths methods, and some of those we call functions. So why do we call some of them functions? So, function test. A function is a relation that has, at most, one y value for any x value. And the way we test this is that it follows what's called the vertical line test. And it's literally what it sounds. Basically, the way this works is if I draw a vertical line, it should only hit the function once. So what I mean by that is if I draw a vertical line at any point, it should only hit the graph once.
Wait, so is that once in one line?
Yeah, so all I've done is every time I've drawn a vertical line, it should only hit the graph once. So in this case, it's hit it here. That's been hit there. One there, one there. But it hasn't hit the graph more than once. There it's passing through.
Sorry.
That's all right. No, you don't need to apologize. Passing through the graph once. Well, if it doesn't, it is what we refer to as a relation. So, for example, in this is a trigonometric curve, which is a what we use for sine and cosine. I like the oohs there. I don't know if that was an actual ooh or whether I was a sarcastic ooh, but I'll appreciate the oohs nonetheless.
Adam went ooh, and I went ooh.
Oh, does that mean well, one sounded happy, one sounded sad. Does that mean that it cancels out and you just equal one? Okay.
It just harmonized.
It just... well, speaking of harmonizers, a trigonometric curve is a sound wave.
Yeah, that's what.
That little duva there. It's a form of sound wave. That's what sound waves look like.
So they use trigonometry for calculating the sound.
They do. So basically, every time I've drawn a straight line, it should only hit the graph once. So it only hit it there, graph once. I think it will make more sense when I do the next example.
Wait, the graph isn't axes or the graph isn't the lines?
The lines, yeah. So it only hits...
I'm with you.
yeah. So for example, if I was to draw a vertical line here, oh look, it's hit this graph in 2 places.
So you can't defy it and just do like a little chip of it or anything?
No, it has to be in every possible place. And as you can see, no matter what I do, I keep hitting the graph in more than one place. Therefore, this is a relation. That's a function. Trigonometric curves are very pretty.
Is the actual thing?
Yep. Yeah, right on the edge. But yeah, it needs to be... unfortunately, the rule doesn't mean once is enough. It's not like, the attitude to homework. One question's enough. Yes, Mr. Schwab.
Is that the actual, is this just a good way to figure out which one's a relation and which one's a function?
Yeah, this is a totes legit way.
Yeah, but is this like the actual way?
Yes.
Okay.
I'm sure you could use algebra to do the same thing, but I think you'll find that, or logic.
It's a common sense thing, maybe.
It's a common sense.
Okay.
If it's a circle, it's not a function.
Yeah.
And similarly here, this one is also a function because it only ever hits the graph once, no matter what I do. And that is an upside down it's a absolute value function, or it's two linear functions put together.
Oh, okay.
The next step to this is, okay, you might remember for that first page we had two different types of functions. There was a one-to-one function, and there was a thing called a many-to-one function. Well, now we have a test to tell the difference between two types of functions. Okay, so we can use what's called the horizontal line test. Now, each of these lovely friends of all functions, because if I draw a straight line, vertical line through each of these, they'll only ever hit the graph once. But there's a thing called a horizontal line test. So if it does both the vertical line test and the horizontal line test, I can distinguish it as being a one-to-one function. So for example, so yeah, we're doing, yeah, it's all very much all passes the vertical line test. Let's see if this passes the horizontal line test. That's the important noise to make while doing lines. And as you can see, it only ever hits the line once, no matter which direction I'm going. So this is a one-to-one function.
Wouldn't they have figured this out when they first did just the function?
Now, for this one here, it's obeying the vertical line test very nicely. But if I do the horizontal line test, you'll see here, it hits the graph in two places. So this is still a function, but it's in fact a many-to-one function. And then we got this friend. So again, vertical line, it's all fine. It wasn't right. And every time I do a horizontal line for this one, it only hits once. That's a one-to-one. And this particular weird friend, this is what would be called a hybrid function. So it might be lying in its bed saying, "Please kill me." But anyway, that's an Aliens reference. So there we go.
He's so proud of himself.
Oh no, right? I am.
Why is it a hybrid?
As
Kind of like a many-to-one.
it's the reason it's a hybrid is you notice how it's gone weird and it's doing this straight line here. It's basically it's a merge of three graphs put together. The reason I know it is that there's no graph in the whole wide world that naturally will do that. So.
Was bit by a radioactive spider.
Well, yes. So as I did the horizontal line test, it actually hit in three places there. So this is again a many-to-one function.
It's just a very special one.
Yeah. One-to-one functions can produce inverse functions. So what does an inverse function mean? Basically what it means is it is the opposite. It's what happens when you reflect a function. What I want you to do here, if I would really appreciate not having to talk over people. Thank you. So what I wanted to do here, I wrote this in a very specific maths language way, which is introduced next year, but I thought you may as well get used to it now. I've got this graph, which is f colon there, 0, 3, arrow r, f of x equals x squared. So what this all means, this is all very complicated looking, but that is just its name. Remember like the polynomial's name? This is the polynomial name. And that there, at the end, is just the equation. So the graph equation. So this is a quadratic. This little duva here, you might remember, or might have remembered from one of our previous assignments, this is the domain. Or in other words, which means what x values they or exist. So in this case, this is saying that this graph starts at 0. That's what the square brackets, it means including. The round brackets means not including, because you can't actually reach infinity or beyond. I'm sorry to ruin your childhood. So basically what that means, what this is saying is, this is the graph of y equals x squared, but starting at 0 and making its way to positive infinity, or to infinity, in that way.
But not beyond?
Not beyond, I'm afraid.
Then what's the other?
The R, oh, thank you for asking for that. What is the R there for? The R is not for pirates. I could double check for you, but last time I checked, it was not.
No, I know that. Yeah, what's after that? What does it say? Are you able to see me?
Yeah, what x values can
What?
Exist. What x values exist?
What is that dot on the?
Has that just been scribbled out?
That's been scribbled out, yeah.
Okay, cool. I was like, what is that word?
It's a maths thing.
I was sat there like, what?
Okay.
Oh.
R is for real numbers, and all it's saying is that all the values that it produces are real.